question at hand is whether or not a ground fault equipment protection, or GFEP, is required for an existing electrical heat tracing system used on safety shower piping when the system is being upgraded but the old piping and heat trace are being reused. The answer, according to the National Electrical Code, or NEC, is yes, a GFEP is likely required to be added. NEC 427.25C3 addresses ground fault protection of equipment for electric heat tracing and heating panels. This section mandates ground fault protection for fixed electric heating equipment used to prevent or remove ice and snow. However, there's an exception, specifically exception No. 2, which addresses existing installations. Exception No. 2 states that existing installation shall not require the addition of a ground fault circuit interrupter, or GFCI, where electrical heat tracing is used on metal pipelines if all of the following conditions are met. Firstly, the circuit is protected by a listed ground fault circuit interrupter. Secondly, the installation complies with all applicable provisions of Article 427. Thirdly, listed equipment is used where required by Article 427. Fourthly, the heat tracing is not used on Class 1, Division 1 or 2 locations. Since the existing installation does not meet condition above, a GFEP is required to be added. Let's break down each of these conditions to understand why a GFEP is likely necessary. Condition A requires that the circuit be protected by a listed ground fault circuit interrupter. A ground fault circuit interrupter is a device designed to protect personnel from electrical shock by detecting ground faults and quickly de-energizing the circuit. If the existing installation does not have a listed GFCI, it does not meet this condition. Condition B requires that the installation complies with all applicable provisions of Article 427, Part Roman 3. Article 427, Part Roman 3 of the NEC covers installation requirements for electric heat tracing and heating panels. This includes requirements for wiring methods, overcurrent protection, and grounding. To comply with this condition, the existing installation must be thoroughly inspected and brought into compliance with all applicable requirements of Article 427, Part Roman 3. This may involve upgrading wiring, replacing overcurrent protection devices, and ensuring proper grounding. Condition C requires that listed equipment is used where required by Article 427. Listed equipment is equipment that has been evaluated and certified by a recognized testing laboratory, such as Underwriters Laboratories or UL. The NEC requires the use of listed equipment in certain applications to ensure safety and reliability. To comply with this condition, all equipment used in the existing installation must be listed for its intended use. This may involve replacing non-listed equipment with listed equipment. Condition D states that the heat tracing is not used on Class 1, Division 1 or 2 locations. Class 1 locations are areas where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 1 locations are areas where ignitable concentrations of flammable gases or vapors exist continuously, intermittently, or periodically under normal operating conditions. Division 2 locations are areas where ignitable concentrations of flammable gases or vapors are not likely to exist under normal operating conditions. If the heat tracing is used in a Class 1, Division 1 or 2 location, it does not meet this condition. Since the existing installation does not meet Condition A, the exception does not apply, and a GFEP is required to be added. In summary, the NEC requires ground fault protection for electric heat tracing and heating panels. While there is an exception for existing installations, the exception only applies if all four conditions are met. Since the existing installation does not have a GFCI, it does not meet Condition A, and a GFEP is required to be added. It's important to note that the NEC is a minimum safety standard. Local codes and regulations may have additional requirements. It is always best to consult with a qualified electrical contractor or engineer to ensure that the installation complies with all applicable codes and regulations. Failing to comply with the NEC can result in fines, penalties, and potentially unsafe conditions. Furthermore, it is crucial to understand the difference between a GFCI and a GFEP. While both devices provide ground fault protection, they serve different purposes. A GFCI is designed to protect personnel from electrical shock by detecting ground faults as low as 5 mA and quickly de-energizing the circuit. A GFEP, on the other hand, is designed to protect equipment from damage caused by ground faults. GFEP devices typically have a higher trip threshold, typically around 30 mA, and a longer trip time than GFCIs. In the context of electric heat tracing, a GFEP is primarily intended to protect the heating elements from damage caused by ground faults. Ground faults can occur due to insulation breakdown, moisture ingress, or other factors. A GFEP will detect these ground faults and energize the circuit, preventing further damage to the heating elements. In addition to NEC 427.25C3, there are other relevant sections of the NEC that address ground fault protection for electric heat tracing. For example, NEC 427.22 requires that electric heat tracing equipment be grounded in accordance with Article 250. Proper grounding is essential for providing a path for fault current to flow back to the source, allowing the GFEP to detect the fault and energize the circuit. NEC 427.23 requires that electric heat tracing equipment be protected by overcurrent protection devices such as circuit breakers or fuses. Overcurrent protection devices are designed to protect the circuit from overloads and short circuits. While they do not provide ground fault protection, they are an important part of the overall electrical safety system. When selecting a GFEP for electric heat tracing, it is important to choose a device that is specifically listed for the application. GFEP devices are available in a variety of sizes and trip thresholds. The appropriate size and trip threshold will depend on the specific characteristics of the heat tracing system. It is also important to ensure that the GFEP is properly installed and maintained. Regular testing of the GFEP is recommended to ensure that it is functioning properly. In conclusion, the NEC requires ground fault protection for electric heat tracing and heating panels. While there is an exception for existing installations, that exception only applies if all four conditions are met. Since the existing installation does not have a GFCI, it does not meet condition A, and a GFEP is required to be added. It's crucial to comply with all applicable codes and regulations to ensure the safety and reliability of the electrical system. Consulting with a qualified electrical contractor or engineer is highly recommended to ensure proper installation and compliance. The NEC is updated regularly, so it's important to stay informed of the latest changes and requirements. By understanding and complying with the NEC, it's possible to ensure the safe and reliable operation of electric heat tracing systems. The implementation of GFEP is a critical safety measure that should not be overlooked, especially in potentially hazardous environments. Regular inspections and maintenance are also essential to ensure the long-term reliability of the heat tracing system and the GFEP.